this video. You'll be able to see it in your YouTube also. In case you are missed a little bit, you can understand that. Alright? Okay. We'll start with the reaction of double decomposition. Double decomposition. This measurement is what I'm saying. It is a reaction between, that there are salt plus an acid. We will be getting a new salt and acid, or salt plus alkali will get a new salt plus a base, and we'll be having salt plus another salt, we get two new salt. What do I mention it this way? That all salts and acid, everything has got two pairs of ions. Now let's take one example. Salt plus acid. Let's take NaCl, Na plus Cl minus 2 ions. It is made to react with S2SO4. So we'll be having S plus SO4 minus. And when the products are seen, we'll be getting HCl plus Na2SO4. HCl is a gas that is escaping out. So what has happened? The reactant there are 4 ions. Product there are only 2 ions, Na2 plus S1, Na plus 1 and SO4 minus and HCl plus S+. So that is what is known as a reaction of double displacement, mutual exchange of ions. This is what I have taken, salt plus acid. The next one is salt plus alkali. Let's take this one, copper chloride, that has got Cu2 plus Cl minus, plus NaOH is an alkali, OH minus and plus, and when the product is same, we will be getting CuOH plus NaCl. Now this is a base that is insoluble. So the reactant there are 4 ions, Cu2 plus Cl minus, Na plus OH minus, and when it comes to CuOH minus, it does not ionize, and NaCl solution. So reactant 4 ions, product there are only 2, and which 2 which are not ionized, we call that as precipitate. So reaction double displacement can also be a precipitation reaction. What is a precipitation reaction? When 2 salts are reacted or any 2 reactants are reacted, an insoluble substance, and that insoluble substance is known as precipitation. Here, copper hydroxide is a base, and bases are known as insoluble alkalis. Isn't it? NaOH is an alkali. Alkalis are metallic hydroxide, which are soluble in water, and bases are metallic hydroxide, which are insoluble in water. So copper hydroxide is a base. The reactant there are 4 ions, but there are only 2. Now the third one is salt plus salt. Let's take this reaction. This is what is given: barium chloride plus Na plus O4. Barium chloride is Bn2 plus Cl minus, Na plus SO4 minus. Barium Bn2 plus Cl minus, Na2 SO4. So when the product is seen, we get BSO4 plus NaCl. BSO4 does not ionize, so that is a precipitate. So reactant there are 4 ions, product there are only 2 ions, and the 2 does not ionize, so that becomes a precipitate. And it is a reaction of double displacement. Remember, the products are formed due to mutual exchange of ions. And one such example which is given in NCERT is the reaction of lubrication. Let's say HCl plus NaOH. HCl plus NaOH will be forming. For example, mutual exchange of ions, the product is this way. We get NaCl plus S2. And here, all the things are in the form of ions. But what has happened? This is rather known as reaction of neutralization. What is known as reaction of neutralization? Acids are those compounds which change the color of blue litmus to red, and bases are those which change the color of red litmus to blue. And when the reaction is taking place, NaCl, that is sodium chloride solution, does not change the color of any indicators. That is, when the products are formed are neutral. The reactants 4 ions, products also contain 2 ions, but it does not dissociate into that, it does not change the color. The products are formed mutual exchange of ions, therefore we call it as also the reaction of double displacement. NCERT says it is mentioned as a reaction double displacement. We can take it as an example. Rather, this reaction is reaction of neutralization. Now, in case asked, explain the reaction neutralizer. This is not mentioned in the NCERT book, but you should know that. When an acid is neutralized by the base or the base is neutralized by an acid, the products that are formed are neutral. Neutral in the sense that indicators don't function over that. No indicators gets the color change. Litmus paper's color will remain the same. Phenolphthaleins color will be the same. Methyl orange color will be, whatever indicators you put, it does not change the color. Therefore, the products are neutral. And the neutralization is also an example of reaction of double displacement where booster excitement. All right. Now the next one is the next reaction is the redox. Redox is important. It is a day-to-day part of life in our this one reaction of redox. Redox is stated as it is split into two, that is reduction and oxidation. Go down, reduction and oxidation. Redox. Now further around, during any chemical reaction, if there is transfer of electrons, transfer of oxygen or transfer of hydrogen, then it is a redox reaction. During any chemical reaction, if there is transfer of electrons, transfer of oxygen or transfer of hydrogen, then it is an example of redox. Now, taking the simplest one, sodium bonds with chlorine to produce sodium chloride. This is a reaction of combination. This we can explain on the basis of redox. How? During the formation of sodium chloride, Na plus 1 and Ca plus. Sodium has an electronic configuration 281, chlorine is having 287. Sodium is having 281, chlorine is 287. So when sodium chloride is formed, this one electron is transferred. The transfer of electron is taking place. The transfer of electron from the sodium to the chlorine has taken place. And this transfer of electron is redox. Now what has happened? Sodium is lost electron. Loss of electron is known as oxidation. So when sodium loses its electron, it forms sodium chloride. So what then we say? Sodium is oxidized to sodium chloride. First part. And see the second part. During the same reaction, the chlorine has gained an electron. One electron which is lost in the sodium is taken by the chlorine. So chlorine has gained the electron. So we can say that chlorine is reduced to NaC. This is an example of the transfer of electron. Sodium is oxidized to sodium chloride and chlorine is reduced to sodium chloride. Now, understood? The next one is the transfer of oxygen. Transfer of oxygen in the sense that when metallic oxide, reduction of metals are important part. FeO, when reacted with carbon, Fe, it forms Fe plus carbon dioxide. During this reaction, what has happened? The oxygen of Fe is transferred to oxygen. So Fe has lost oxygen. And loss of oxygen is known as reduction. So FeO is reduced to Fe. And addition of oxygen is oxidation. To this carbon, oxygen is added. So we can say that carbon is oxidized to carbon dioxide. Understood? First one was sold, transfer of electron, and here goes transfer of oxygen. Understood? The next one. CuO, when combining manganese, red oxide, copper oxide, and hydrogen is passed, the reaction goes like this way: Cu plus S2. Copper is lost, hydrogen has gained oxygen. Similarly, the reaction goes on. So transfer of electron, transfer of oxygen. So therefore, you know down. During oxidation, in an oxidation reaction, addition of oxygen, removal of hydrogen, or removal of electrons take place. And for the reduction, just opposite of oxidation. Means addition of hydrogen, addition of electron, or removal of oxygen. Understood the examples? Next, now, down. All oxidizing agents undergo reduction, and all reducing agents undergo oxidation. All oxidizing agents undergo reduction, and all reducing agents undergo oxidation. Therefore, here carbon is oxidized, therefore it is a reducing agent, and FeO is reduced, therefore it is a oxidizing agent. Every reaction might be having number of reactants, but what is important? One reactant will be oxidized and another reactant will be reduced. The one which is oxidized will be the reducing agent, and one which is reduced will be the oxidizing. Now, why did I mention? Because board examination, they will give you an equation and ask you to find out what is oxidizing and what is the reducing agent. Or if not, what is oxidized and what is reduced. So, oxidizing agent and reducing. What is oxidized will be the reducing agent and what is reduced will be the oxidizing agent. Concept is clear? Anyway, everybody understood it? Thumbs up. Okay. The next one is, after this redox, is what we must do is rancidity. Rancidity is the process those food materials which have water and oil, if not refrigerated, left outside for a few days, a few hours, the taste of the food gets changed, the color will get changed, the smell will get changed, the texture will get changed, and then we say the food is gone rancid. And that process is known as rancidity. Especially during this reason, if you cook rice and leave it outside for a few hours, and not refrigerate, leave it outside, then what is happened? After a few hours or after next day, when you come and check it out, you can see all its structure gets changed. The color, taste, smell, texture, everything is changed. We say the food is gone, rancid, and the process is known as rancid. To prevent rancidity, you must understand the food materials are getting spoiled due to the presence of bacteria. So we must make the bacteria inactive, or we must make the bacteria to get killed. And that is why here is what is bacteriostatic and bactericidal. Sterile means the bacteria are to be killed, and bacteriostatic means it must be stationary. And what happens? The bacteriostatic method is employed when we keep the food under refrigeration. When you keep the food under refrigeration, then what happens? The bacteria remains stationary, so the food does not get oxidized. Food does not get oxidized. The next one is when you boil the milk, what happens? The bacteria present in the milk gets killed and the milk remains safe. After a few hours, again you heat it, the bacteria will get killed and then there is bacteriosis. But every time one cannot do all these things. And that is why all these dairy products, for example, this cream and etc. you get from the market, it is mentioned once open, keep it under refrigeration. And how it is packed? It is being packed, vacuum packed. Vacuum packed in the sense that the container does not have any oxygen, does not have any water. The food will be getting spoiled in case if it has got oxygen or in case it has not. If these two things we can eliminate, then the food will not get spoiled. That is not possible. Industries they cannot that. So that is what to prevent lancility, what we do. First one is we pack it in airtight containers. Like normally people say that if you open the packet, keep the lid tightly closed. Take something and keep it tightly closed, then it will not be spoiled for a long time. And if you keep it not tightly closed, air and moisture can enter it and it will be spoiled. The second one, you keep it under refrigeration, that will remain inactive. It is. And the next one is what is the normally antioxidant. Antioxidants are certain chemicals added. Antioxidants are certain chemicals added to minimize the oxidation. The food is getting oxidized with oxidation. Acidity is an oxidation process. So that oxidation of food can be prevented when we put some antioxidant along. This is all what happens in the industry. People when they pack, they put antioxidant and pack it to prevent the or to minimize this. The next one is it must be packed in inert atmosphere. It must be packed in inert atmosphere. You all know that inert gases are helium, neon, krypton, xenon, radon, all these gases, they are inert, they are known as rare gases. Why they are known as rare gases? Because in atmosphere, they are present in very, very less amount. It is mentioned that these potato chips are being packed in inert atmosphere of nitrogen. So you can ask, then how come nitrogen is used? You know that nitrogen is one of the stablest gas available in the atmosphere, which is abundantly available. 76 to 78% of atmosphere is nitrogen. So these potato chips, if it is packed in inert atmosphere of nitrogen, then what happens? That will not get spoiled. You know that nowadays the 4-wheelers are being filled with nitrogen gas. People say that nitrogen is filled, the oxidation of tire or rubber gets minimized. So your tire will have a longer life when it is filled with nitrogen. Because when the vehicles are running on the road, the temperature gets risen, the tire will get oxidized. That is an oxidation. And in case inside it is filled with nitrogen, the oxidation of rubber will be minimized, the tire will have longer life. That is advantage of it. So potato chips are being packed with inert atmosphere of nitrogen. Now why nitrogen is used? Because it is abundantly available in the atmosphere, only you have to isolate it. And why can't it be filled with other inert gases? Helium, neon, argon, etc. If these gases are to be isolated from the atmosphere, and that becomes very, very, very expensive. Therefore, that cannot be used. So that is, it is filled with nitrogen, inert atmospheric nitrogen. Nitrogen is a gas which is not inert, but chemically it is rather inert in nature. Nitrogen to get react extreme high temperature, presence of voltage, etc., etc. is needed. You know that during thunder and lightning, millions of volt, the nitrogen gets converted into nitrates, and that is how plants get it. You know that after the first shower, the plants will be having a brighter life because they get nitrogen as a primary nutrient from the atmosphere. How the nitrogens are being converted into nitrate, and that comes to earth through rainwater, and the plants get it. Otherwise, why can't the plants absorb nitrogen from the atmosphere? Because it is inert. When we breathe in air, we are taking in air along with nitrogen. Nitrogen goes in and nitrogen comes out. Your body cannot absorb nitrogen because nitrogen is a stable body. Oxygen is not. Oxygen, all molecules are stable. Every molecule requires certain energy to be broken. That's what it is. Every molecule requires certain amount of energy to be broken down into its atom. But nitrogen, it requires very large amount of energy. Therefore, nitrogen is used for filling up. So very important. Keep it in airtight containers, pack it in inert atmosphere nitrogen, use antioxidant, keep it under refrigeration and all these processes. That's what clearly okay. Along with this, the next one is after this activity is a corrosion. Corrosion is also a type of oxidation. All metals are electropositive in nature. Metals have the tendency to lose electron. And anything comes to the metal, when it loses electron, what has happened? It gets oxidized. That's what it is. So that process is what is taking place in rusting of iron. Corrosion of iron is known as rusting. What is corrosion? Destruction of any metals when it comes in contact with atmosphere. Atmosphere means many consequences are there present in the atmosphere, but most important one is oxygen, carbon dioxide, water molecules, these things. So many metals get corroded in atmosphere in different methods. Now, iron get corroded in atmosphere, and that corrosion of iron is what we call it as rusting. And to iron to get rusted, what is needed? What it says that humid air is needed. Humid air contains oxygen and CO. This is needed for iron to rust. Humid air. Now, how does iron get rusted? You know that when it is surrounded by oxygen and CO, all metals being electropositive in nature, this Fe has the tendency to lose electron. And when it loses electron, these lost electrons are being taken away by this oxygen and SO. Fe is oxidized, Fe is corroded, Fe is lost. So one such method to prevent the corrosion is the electrons lost by the Fe should not be taken away by this. So what has happened? Along with Fe, it could have more reactive than zinc. The metal activity series, you know that zinc is more reactive than Fe. So what has happened? Fe is ready to lose electron, oxygen and water molecules are ready to accept, but zinc is also ready to lose electron. Zinc is more reactive. Zinc loses electrons very fast. So what has happened? Oxygen and H2O takes the electron of zinc, and Fe's electron is not takes, so the zinc is. And that method is galvanization. Coating of zinc, coating of Fe with zinc, or any metal which is more reactive. That is what is galvanization or sacrificial method of protection. We prevent Fe's corrosion by sacrificing Fe metal. And that is what is known as sacrificial method, which is galvanization. The second method is the metal we cover it with paint. There are only two methods to prevent the corrosion. One, we must attach a metal which is more reactive than Fe, then its corrosion does not take place. And the second one, we must cover it with paint. And when it is covered with the paint, what has happened? When it is covered with the paint, oxygen and water molecules are not able to come in contact with the metal, corrosion is prevented. One is we sacrifice one metal for the sake of Fe, and another one we sacrifice, we cover it with paint. But paint, when painting is done, a little bit of paint is removed, and the corrosion will begin from there. So we have to repaint. And whereas when galvanization is done, in case the metal has zinc anywhere on the metal, little zinc is somewhere available, and that will not allow Fe to rust. That is the difference. And the material is painted. What has happened? The paint, once the paint is removed, the corrosion will begin from there. And when it is coated with zinc, then what takes place? The zinc, as long as the metal has zinc, it will not corrode. This is how the corrosion can be controlled. Understood it clearly? That's all as far as that chapter is concerned. I'm ending the meeting. All right. One day we'll see to that. All right. So take care. Do that.